Hello, this is John from TC Math Academy. And in this particular video, we're going to multiply complex numbers. So this number here is a complex number, and this number here is a complex number. So we're going to find the product of these two complex numbers. This is something that you're going to learn in probably, we might study this a little bit in Algebra 1, but certainly if you're taking any course like Algebra 2, College Algebra, or beyond, you really get heavy duty into complex numbers. This is very, very important in mathematics. I'll explain to you very quickly in a moment what a complex number is. But before we do that, if you can figure this problem out, go ahead and put your answer into the comment section. Of course, I'm going to show you the right answer, then we'll talk about what a complex number is and exactly how to find the product in this particular problem. Also, if you need math help with the course you're taking, test prep, or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to it in the description below. Also, if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and show you the answer. And then we'll talk a little bit about what a complex number is. Now, if you're looking at this, you're like, I have no idea what you're talking about. Well, it's a good chance that you have not yet studied complex numbers, but you definitely will if you continue your studies in mathematics. But let's go ahead and take a look at the answer of the product of these two complex numbers. It is this. It's another complex number, negative 14 plus 22i. That is the answer. All right, so how'd you do? Well, if you got this right, let's go ahead and give you a nice little happy face, an A plus, a 100%, and a few stars so you can tell your friends and family that you know how to find the product of complex numbers. They'll be very impressed with that information. Okay, so before I show you exactly how to do this problem, let's just quickly review what a complex number is. So when we start learning mathematics, we start learning a number system called the real number system. And there's kind of different ways you can write it. It's usually like a big R. It's the set of real numbers. I'm getting kind of very technical sounding in terms of mathematics, but let's just kind of review some basic things. The first thing you learn is what we call the counting numbers or the natural numbers, right? And things that we see in like our actual reality, right? So you see like one car, oh, there's two cars, there's three cars. Or if you look at your fingers, you're like, oh, there's one finger, there's two fingers. So our counting numbers are like 1, 2, 3. These are also called the natural numbers, et cetera, et cetera. All right, so these would be called the natural numbers or counting numbers. So as time went on, someone said, "Hey, look, how do I express, zero?" I mean, that's a concept, right? So you can imagine, like cavemen running around, and one caveman looks at another like, "Hey, did you see any, buffalo or anything like that?" They're like, "No, I didn't see any." So instead of showing some hands, they needed to come up with a symbol that says, "Hey, there is none." So we would add in zero, and so this here is an example of what we call the whole numbers. Now, if we take the positive whole numbers and then we add some negative whole numbers to it. So in other words, we're going to take these same values, 1, 2, 3, 4, and then we're going to make these negative like so. Okay, and this, of course, this goes on and on and on. What set are we dealing with here? Well, you're dealing with the integers, and then we can go to the rational numbers, which are fractions that we can construct using any integer. Let's say like 3 and 4. So the number 3/4 or any number that you can express as a fraction of integers is what we call a rational number. And then any number we cannot express as a fraction is something called an irrational number, something like pi, 3.14, et cetera, et cetera, et cetera. These are what we call non-terminating, non-repeating decimals. So this whole entire set is called the real number system. Now, some of you might be like, oh my goodness, why did you have to go through this whole thing? I just want to know how to multiply these two things. Well, because it's important that you understand, with the real number system, because the real number system is because we are talking about another number system. So the real number system, again, is on zero. Here's zero like in the middle. Then here it goes positive. Here it goes negative. All these numbers I just talked about are on the real number line. So this is what you study, in elementary school, middle school, and into high school. And, you run into problems, let's say like this, x squared is equal to 16. Okay, so how do I solve this equation? Well, here I would just simply take the square root of both sides. So x is going to be equal to the square root of 16, which is positive negative 4, because positive 4 times positive 4 is 16, and negative 4 times negative 4 is also a positive 16. No problem. 4 and negative 4, here is 4 and here is negative 4. Both of these numbers, both of these solutions reside on the real number line. They are part of the set of the real numbers. Okay, so now finally let's get to what a complex number is. So let's take our problem here. X squared is equal to 16. And I just showed you that x is equal to plus or minus 4. So because we take the square root of both sides, we get x is equal to positive negative 4. These, of course, again, are in the real number system. All right, what about this situation? X squared is equal to negative 16. Well, I can't even write a negative 16. I'm so excited about talking about complex numbers. All right, there you go. X squared is equal to negative 16. So if you have a calculator handy, all right, maybe you can pull one up on your cell phone, or if you don't have a fancy calculator, maybe on your laptop, computer, whatever the case might be, try to take the square root of negative 16. Okay, yeah, if you're not dealing with a pretty sophisticated calculator, like a basic calculator, chances are your calculator might start to tremble. It might even kind of have a little bit of smoke coming out the back of it. It's like, it's not understanding the question. All right, you're going to just likely see some sort of error message because your calculator is not understanding. What are you talking about? I don't know what. Remember, the square root is, you're trying to find two exact numbers that equal this number. So, excuse me, like in the case of square root of 16, we are looking for two numbers that are exactly the same, that is equal to 16. So 4 times 4 is 16, and negative 4 times negative 4 is 16. But what about negative 6, or negative 4 times negative 4 is positive 16. But how can we possibly get two numbers that when we multiply them together, we get to a negative 16? Well, it's impossible, because a negative value is going to be either this is going to be positive and negative to get a negative, or negative and positive, so you can't. So your calculator doesn't understand that. Well, here's the deal. The answer to this question, because this is an equation, this is a quadratic equation, there is a solution, okay? There's this thing called the fundamental theorem of algebra that states that, yes, indeed, there will be two solutions to this quadratic equation. But here's the deal. They're not going to be in the real number system. You're going to have to look in the complex number system. Okay, so the answer to this would actually be a complex number, or an imaginary number. All right, so complex numbers are tremendously important in mathematics. And let's just kind of break it down this way real quick. So here is a complex number system. The real number system actually lives inside of the complex number systems, the complex number system, excuse me. And complex numbers are basically formed like this: a plus bi. This is the basic form of complex number, where a, okay, is the real component, and b is the imaginary component. So just a quick power review of complex numbers. Now I'm going to get into a little bit more what the imaginary number is, but this is why complex numbers are tremendously important. You will absolutely be dealing with complex numbers as you progress in mathematics, especially if you're at the Algebra 2 level or beyond. All right, so for those of you out there who just didn't know or curious, this is kind of where we're going. This is why, doing a problem like this is important, because we're doing operations with complex numbers. And we have this kind of concept in mathematics called closure. And it's kind of a fancy concept. I'm really not going to get too much into it. But basically, it states that, hey, when you have a complex number, if we multiply one complex number by another complex number, the answer will be in the set of complex numbers. So here, our original problem was one complex number. We're multiplying by another complex number. What's the answer? Well, the answer happens to be another complex number. So anyways, that's an example of what we call closure in sets in mathematics. Kind of fancy language and stuff. What you need to know specifically is, how do you find the product of complex numbers? All right, now there's other operations you need to know, how to add, subtract, and whatnot, but we're going to focus on multiplying complex numbers, and let's get into the problem right now. Okay, so the main idea here is that you're going to want to use the FOIL technique, all that good stuff that you learned back in Algebra 1. Now, the FOIL technique is first, outer, inner, last. Now, you don't even have to use the FOIL technique. What you have to do is use the procedure that you learned how to multiply two binomials. So if I gave you this problem, x plus 2 times x minus 1, how do you find the product of this? Again, this is like pre-algebra, algebra 1 stuff. You need to know how to do that. Most students out there use that FOIL technique when multiplying two binomials. So I'll just kind of delineate this. Hey, we'll use the FOIL technique. Again, our answer is going to be a complex number. That's going to be an a plus bi form. Now let's talk about this bi. Remember, a is the real component and bi is the imaginary component. So this imaginary number, is equal to the square root of -1. That's what you need to know. So if I is equal to the square root of -1, I squared is equal to -1, right? So if I square both sides here, I get I squared, and that's equal to -1. This is going to come in very handy in just 1 second. Okay, so now that we know what a complex number is, why it's so important, and we have a kind of a basic outline in order to multiply two complex numbers, let's go ahead and do this problem now. So, for me, when I teach math, or do these little videos, I could do this problem in like 3 seconds. I could like or not 3 seconds, 30 seconds, 1, 2, 3. I know what I'm doing, but I like to fully explain all the relevant concepts involved here so you can walk away with this video with like not only understanding how to find the product of complex numbers, but kind of the bigger picture, understanding why this is important. All right, so here is kind of like the FOIL technique, and you can see I'm going to be multiplying our first, which is 3 and 2. These would be like our first, right? And then our outers, there's 3 and 4i. That would be our outer, and then 5i and 2, that's our inner, and then our last are 5i and 4i. Again, basic Algebra 1 review. If you need help with any of this stuff, if you're actually studying complex numbers, probably want to check out like my Algebra 2 course. It's probably the best course for you. If you happen to be in pre-calculus, I teach this stuff in pre-calculus as well. All right, so we're going to go ahead and do all this multiplication. Let's go ahead and take a look at the results of doing that right now. All right, so 3 times 2, that's our first. That's 3 times 2 is 6. Then we're going to take this 3 and multiply it by 4i. This is our outer, first outer, right? So 3 times 4i is 12i. So when you're multiplying this 3, just multiply by the coefficient. Just kind of treat that I almost like a variable. So that's 12i. Then now I'm going to do our inner, first outer, inner, last. So 5i times 2, that gives me 10i. And then our last is going to be 5i times 4i, which is going to be 20i squared, because you got I times I is I squared. All right, so now we're going to go ahead and combine like terms. So I have a 6. There's no other numbers, but I can combine these i's here. So 12i plus 10i gives me 22i, and then I have my 20i squared. All right, so we're getting pretty close to the final answer, but what we need to do is look at where we're at right now. Okay, remember, we know that the final answer is going to be a complex number written in a plus bi form. But right here we have this I squared, so we have to get rid of that I squared. And remember, I told you I is equal to the square root of -1, so I squared is equal to -1. Okay, so we're going to replace that I squared with a -1, and you're going to see how easy it is to do this problem. All right, so I squared we're going to replace with a -1, and then we're going to just go ahead and substitute that -1 for I squared. Let me go ahead and scroll down so we can see the rest of the problem. So 20 times -1 is -20. So we have 6 plus -20, of course, is -14. That's our real number part of the complex number. And then we have our 22i right here. So this is a complex number written in a plus bi form. Okay, so I know I kind of gave you extra information there on complex numbers, why they're so important. But here's the deal. The more you understand all the relevant kind of, topics, involved in this, because math is a huge topic, it's like there's so much to learn, and it's all interconnected, but you want to kind of review some of that basic stuff that you learned and see how it's connected to the more advanced stuff because it all is connected. All right. Again, if there's anything about this problem you don't understand, you want to review it. Maybe it's the FOIL technique. And you're like, you know what, I'm struggling a little bit on multiplication of this. Maybe it's something else, the distributive property, positive, negative numbers, whatever the case might be. Maybe it's me kind of going over some basic quadratic equations. Whatever you identify as not you struggling with, right? Here's the deal. It could even be, peripheral to this problem. You're like, you know what? I don't understand this. If you have something very specific that you don't understand, that's actually that's a very good thing because you can specifically work on improving that skill. Now, you may have to work on other skills in order to improve this skill, but at least you have a starting point. The worst thing is, me giving you a math problem and you'll be like, I don't get anything. I don't understand nothing. I'm like, where do I start? If that's your situation, well, what you need to do is go back to the foundations. And we are talking about Algebra 1, Algebra 2 stuff here. So again, if you need help with any of this stuff, just go to my Math Help program. I got plenty of help there. Of course, you can check out my other videos on my YouTube channel. But if this particular video helped you out, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.